And what about Shahid? How is it
Yes, sir.
going? How is it going in everything in maths?
Everything is good.
Okay. And did you attempt the last test on Friday?
Yes, sir.
Okay. And how's the preparation for JE?
That's what I'm doing.
Okay. Are you attending more classes? Like, are you attending
No,
other
sir.
classes?
No.
Okay. Shahid, you will need to attend different set of classes if you also want to prepare for JE.
Yes.
Oh, uh, hi, Mariam Parkar. Hi, Mariam. Is it your first class?
Sorry, sir, I by mistake joined this class.
Okay. Yeah, so I gave 3 questions in the last class and also first 8 questions from NCRT, I guess. So did you solve these questions? Okay, so let's start with the first one. I guess this should be the first, yeah, fifth, sixth, seventh, or fifth we have done already. Yes. So you have to start with this one, sixth, seventh, and eighth. Let's start with the first one, sixth. What was the differentiation of GX in this case? Anybody can share the answer if we are solved it. Yeah, so first is, in this case, the first differentiation is of given of root, square root, sine cube x into cos 2 to the power x. So first the whole expression contains root. That is why we'll be applying the formula. I mean, with analogy to this formula, the d by dx of root x is equals to 1 by 2 root x, right? So first we'll start with 1 by 2 inside root the same quantity, sine cube x into cos to the power, cos of 2 to the power x. Okay. which we can also write as 1 upon 2 gx, right? We have previously done it, many times. So 1 by 2 gx into, now we will start with sine cube x into cos to the power cos of 2 to the power x. There are two different functions. One is sine cube x and another is cos of 2 to the power x, and they both are given in multiplication. So we will be applying product rule, right? Product rule on these two terms, where first term is this and second term is this, right? So we will take, at a point, we will take one function constant and differentiate another, and then add them. Right? So first we are differentiating sine cube x. Sine cube x will be first the power, sine to the power 3x is given. So first power 3 into sine square x. Right? Reduce the power, take the power outside and reduce the power by 1. Then we will go to sine x. The differentiation of sine x is cos x. Okay. And cos 2 to the power x will be taken as constant. Right? Plus, now we will take the first term constant, which is sine cube x in this case, and we will differentiate cos of 2 to the power x. Now we know the differentiation of cos x, but not cos 2 to the power x. So that is the point where we know that we have to apply chain rule. So cos of 2 to the power x, first let's go to cos. The differentiation of cos, there is no power involved. The power is inside cos, not on the cos. So that is why we will start differentiating cos directly. The differentiation of cos will be minus sine. Inside 2 to the power x remains same. Now into, now we'll reach to 2 to the power x. 2 to the power x is 2 to the power x log 2 of ln 2. Yeah, Shahis, you're asking for something. Okay. So now we can further, I don't think we can simplify it much. You can only take sine square x common. Other than that, we have nothing common in both of the expressions. So we can further write this as 1 by 2. This expression can be written as gx into, we can take sine square x actually common. So this would be sine square x. And then here we will be left with 3 cos x into cos of 2 to the power x minus, this would be sine x, sine of 2 to the power x, 2 to the power x ln. This would be a final term for g dash x. Are you done with this? If somebody is still writing, then please just raise your hand. Okay. Oh, we've already solved 8-1. So we only have 7. You guys solve this quickly. Let's find out what is g dash x in this case. Guys, please, everyone solve this. This is a good question. If you are solving it correctly, then you have understood the chain rule completely. I can say that. So everyone, please solve this question. Yeah, so do we have an answer?
Yes, sir.
Please. डायरेक्ट बोल सकते हैं शाविस?
1 by 2 root c into 2 raised to x into root log x into c 2 raised to x into root of log x into tan of 2 raised to x into root log x into 2 raised to x log 2 into root log x plus 1 by 2 root
Okay,
log
okay,
x.
wait. Let's simplify the whole expression. You tell me one by one what is the differentiation of everything. Okay, so whatever you first said, 1 by 2, then root over sec 2 to the power x root of log x, that can be written as gx. And we have already seen this, that this is the pattern that we can write g if the whole expression is inside the square root, right? So we can directly write g dash x. We can directly start writing g dash x as 1 upon 2 gx, right? So whatever that expression was, that we can replace with gx. Now we will, so we have done the differentiation of root. Now what? Now tell me. Next step would be the differentiation of
Sec.
sec, right? So what would be that?
Sec x tan x.
Sec x tan x. In this case, that can be written as sec of 2 to the power x root log x into tan of 2 to the power x root log x. Right? Oh, sorry, just. Yeah. After this, we will reach to
Inside bracket.
yeah, and that would be, now what should we apply?
Product rules.
Product rule, and that will be applied like
First differentiate 2 raised to x, then multiply constant.
yeah, we can keep one function constant and differentiate another. Yes. Now, what would be the expression for this?
2 raised to x into log 2 into root of log x.
Correct. Only this?
Plus 1 by 2 into root of log x into 1 by x into 2 raised to x.
1 by 2. Now we will do the differentiation of root log x. 1 by 2 root log x into 1 by x. So this would be the first differentiation of root, then log x, which would be 1 by x. Right? So this would be the whole expression of your g dash x for this case. But remember this is all in numerator, right? And the denominator is upon 2gx. I hope everybody is done with this. If somebody is still writing, then please just raise your hand. Cool. We'll start with inverse differentiation of inverse trigonometric functions, ITF, today. And the differentiation of ITF is different because we need to understand ITF for differentiation, although we have already studied ITF now. So we do know some of the substitutions. So we have to first reduce the whole function. Now I'll first show you what is the problem. So let's say, first of all, we do know some things by now. So today we will be discussing ITF, inverse trigonometric function differentiation, right? Just give me a minute. Yeah. So to begin with, first, let's start with the formulae part. We do know these 6 formulae. First is differentiation of sine inverse x with respect to x, obviously. Then second is if x is not present here and something else, some other function is present, then we do know that we have to apply chain rule. We can also do that, but we have to apply chain rule, right? Then differentiation of cos inverse x with respect to x. We do know that. Then the differentiation of tan inverse x is also known to us. These three are will be the most used formulae, but I'll also write the other three, but these three will be the most used, and you have to remember these three. And they are very pretty simple to remember. You actually have to remember 2 formulae only. Sin inverse x is 1 upon root over 1 minus x square. Similarly, cos inverse x will be minus times of this. And then tan inverse x is 1 by 1 plus x square. Although we know that there are 3 more trigonometric functions, and the differentiation of them will also be simple to understand. So in this case, cot inverse x will be minus times of tan inverse x. This will be 1 upon x into root over x square minus 1, and then this will be minus 1 over x over root x square minus 1, right? So we do know all the formulae part, but what if, let's say, the differentiation occurs like this? What's the issue here? The issue is basically, let's first start with this problem. So let's say instead of sin inverse x, we are giving you, I mean, we are not just using this trigonometric function directly. I mean, we can have problems like this, x into sin inverse x. Right now, there are 2 functions, right? And we do know how to differentiate this. There are 2 different functions which are in product. So we will apply product rule. First, we will differentiate x. Differentiation of x is 1. Sin inverse x will be as it is. And then x will be as it is. Differentiation of sin inverse x will be 1 over root 1 minus x square. So one application of these ITF is that we can use them in product or in quotient rule with some other function. Right? But then there can be another application, which is we can take composition of this trigonometric function, right? So we can write differentiation. We want to know the differentiation of sine inverse x square now, not x. Now, if we have this problem, then we do know the solution. We will apply chain rule, because we know the differentiation of sine inverse x, but we don't know the differentiation of sine inverse x square, right? So we'll apply the chain rule. First, we will differentiate sine inverse. Sine inverse will be 1 by root over 1 minus input square, right? Input square is, this time input is x square itself. If you are squaring x square, then you will get x to the power 4, right? After this point, I'll reach to x square now and differentiate x square. Differentiation of x square will be 2x. Now, another kind of variance for second problem will be if we make the function difficult. For example, in place of just x square, now I am replacing it with e to the power x, or maybe something like that. E to the power Sine inverse x. Can you solve this? Try it, everyone. First, you guys try, then I'll share the approach how to solve this. Now this is again composition of function, right? You have placed some function inside sine inverse x. So instead of using x in sine inverse x, you are now using e to the power sine inverse x. First, let's start with the leftmost function, which is sine inverse. We know the differentiation of sine inverse. We just have to replace x with e to the power sine inverse x in that function. And the answer is correct, right? Good, very good. So now we can start with this sine inverse. So first, let's start with sine inverse. The differentiation of sine inverse will be 1 over root 1 minus, right, e to the power sine inverse x whole square. Also, you can multiply sine inverse x into 2. Don't make it e to the power sine of minus 2x. I mean, always remember here, sine inverse x whole square is not written as sine to the power minus 2x. They both are different things. Sine inverse x and sine x to the power minus 1 are two different things. Sine inverse x in itself is a function. I mean, I'll also elaborate in the basics here. Sine inverse x, it's a function, right? What kind of function? Inverse trigonometric function, right? But if you're writing sine x to the power minus 1, this is something different. This is basically 1 upon sine x. And 1 upon sine x is what? Cosec x. Inverse function. This is trigonometric function. The key difference between them. So this will be, rather what you can do in this case is you can multiply sine inverse x with 2. If you write 2 to the power 3 to the whole power 4, then you can do what? You can multiply actually 3 and 4. So that is what you can do here. You can multiply sine inverse x with 2. So this will be written as e to the power 2 sine inverse x. Okay, replace the whole expression, just simply that. E to the power 2 sine inverse x, right? Into, now we will reach to e to the power sine inverse x, which is an exponential function basically. E to the power x, instead of e to the power x, you have written e to the power sine inverse x. So the differentiation of e to the power x is e to the power x. So in this case, it will be e to the power sine inverse x. Now you will reach to sine inverse x. The differentiation of sine inverse x is 1 over root 1 minus x squared. This would be the final answer. These are another kind of variants which you can see, but you can solve them basically easily using the chain rule itself. But we can further change these questions. I think everybody is done with this, right? If you haven't written something somewhere, just raise your hand, okay? Right there. I'll understand that I'll have to scroll up and you need to note down the last question or whatever you've written last. Now, another kind of variant to these kind of questions is where we involve a big algebraic function inside a inverse function. For example, the questions given in your NCERT starting from question number 9. So let's take the question number 9 only. We have y is equals to sine inverse 2x upon 1 plus x squared. Now, obviously, you can do this with chain rule also. I mean, you'll have to apply chain rule maybe after this, but if you want to differentiate this function, if you want to know the answer of dy by dx, you can do that. Let's even do that. But you will observe that to do this with chain rule, you'll need to simplify a lot. For example, if you are differentiating this function, then you will first differentiate sine inverse. The differentiation of sine inverse x is 1 upon root over 1 minus x square. So this would be 1 upon root over 1 minus 2x into 1 plus x square whole square. And the point is that you can simplify this. This will be a big simplification, no denying that, but you can obviously simplify this, right? And if you start simplifying this, it will consume a lot of time. So to counter with that problem, we need to understand another methods to solve this. But because we have already started, so let's do this now, complete this. So this would be, now we will reach to 2x upon 1 plus x square, which is basically applying quotient rule. Applying quotient rule will be 1 plus x square whole square. Okay. Then differentiation of 2x. Differentiation of 2x will be 2 into denominator as it is, minus 2x as it is into differentiation of 1 plus x square. 1 will be 0, x square will be 2x. And you can further simplify the whole expression. This will reduce down to some very simple expression. Okay, let's reach to that expression also. Okay, so I'm going to simplify this. You can square these terms and then take LCM, and then after that you'll reach to this answer only. Let me do this for you. This will be simplified to this, then divided by 1 plus x square whole square, and this will be 2 plus 2x square minus 4x square. So this will be 2 minus 2x square, right? And 2 you can take common, so this will be 1 minus x square. They both will be cancelled out. This will be 2 upon 1 plus x square whole square. Now you see how simplified that expression is. 2 divided by 1 plus x square whole square. This can also be minus 2. I'll have to check for that. But yeah, the answer must be plus minus 2 divided by 1 plus x square whole square. But how simplified that expression is, right? But we need to, spend at least 4 to 5 minutes to get to that. We don't want to consume this much time to solve this. That is why we have another method, how we can solve this kind of inverse trigonometric functions, where there are larger expressions for, there are larger algebraic expressions. And always you will see that there will be algebraic expressions involved. No other expression than algebraic expressions. Why is that? Because we can simplify, or we can reduce these expressions if we put the right substitution here. In place of x, if we substitute it correctly, then we can reduce this function into a more simple function, and then it can be differentiated directly. So for that, we need to understand the substitutions involved here, and which we have already done in, I guess, inverse trigonometric functions. Let's go to inverse trigonometric functions. I do not remember the here we have written these kind of things, but we should have written somewhere. Yeah, reduction of ITF forms. And we must have written substitutions. Yeah, these were the substitutions. If you ever see 1 minus x squared, then, and in fact, basically, I told you that these kind of substitutions are arrived from your formula part only, because why you are putting 1 root over 1 minus x square, x is equals to sine theta, because it can actually reduce the square root and make it a simple expression. If you put x is equals to sine theta in this case, then this will be 1 minus sine square theta. And similarly, we need to also remember some formulae, and the formulae part are sine 2 theta, cos 2 theta, tan 2 theta, the formula of formula for them. We must have discussed. Yeah, sine 2a can be written as 2 sine a cos a, and also 2 tan a upon 1 plus tan square. Right? Now we need to understand in these how to apply these formulae. Right? So cos 2a, I have also told you to remember the formula for cos 2a and tan 2a. So these are important formulae because now you will see the application of these formulae in these kind of questions. Let's start with fifth part. So here it is given sine inverse 2x divided by 1 plus x square. Now we have just seen the formula for sine 2x in terms of tan. If you replace x with tan x, so this whole thing inside this algebraic function becomes 2 tan x divided by 1 plus tan square x. And that can be written as sine 2x. Sine 2x can be written as 2 tan x divided by 1 plus tan square x. And this is the same algebraic function which is given in this case. Now, why is that happening? Because if you put x is equals to tan theta in this case, then this whole function will become sine 2 theta. Now, sine inverse can be removed with the help of sine. Sine inverse of sine can be removed directly. I mean, not directly, but in your syllabus can be moved directly. So sine inverse sine 2 theta can be written as just 2 theta, right? So that is how these questions will be given. There will be a formula from trigonometry which will fit directly to your expression. Okay? So you need to replace your x with that formula. I mean, replace with x with some trigonometric function to solve that given question. For example, in this case, this is the first method, calculating. This is calculated, time consuming. And this was, I would like to say this, that even this was easy. We will face certain more complex situations with other expressions. So this can be made much more difficult. So, but as I told you, we do have second method. Let's apply this. Let's understand how to apply this. So the first point is compare the given algebraic expression with some trigonometric formula. For proper substitution. So in this case, what we have is we have y is equals to tan inverse, sine inverse 2x upon 1 plus x square. So 2x upon 1 plus x square can be made 2 tan theta divided by 1 plus tan square theta if x is equals to tan theta. Understand this part. This 2x upon 1 plus x square can be converted, can be transformed to 2 tan theta upon 1 plus tan square theta if you just replace x with tan theta. Now, can I do that? Yes. I mean, for some value of x, for some theta, x can be replaced as tan theta. Right? We won't, I mean, we are not specifying about theta. Right now, we have introduced a new variable, but we will convert it finally to x only. I mean, we will change theta in terms of x. We can easily do that. Because, I mean, from this expression only, if I take tan from right hand side to left hand side, it will become tan inverse x is equals to theta. So finally, I will replace theta with tan inverse x. But for now, because the whole expression simplifies to a very simple thing, I'm just replacing this whole thing, sin inverse of 2x upon 1 plus x square. I'm just replacing x with tan theta in this expression. So by replacing x is equals to tan theta, tan inverse x is equals to theta ban jayega, right? But for now, the expression will be y is equals to sin inverse x. So put x is equals to tan theta. This will become sin inverse of 2 tan theta divided by 1 plus tan square theta. Which is equal to sin 2 theta, right? So this whole expression will become sin inverse. Yeah, Charles.
So like we can put tan theta, we cannot put here sin theta.
You can put sin theta, but if you put sin theta, then it will become 2 sin theta upon 1 plus tan square theta. And this is not a formula to, I mean, this will not help us to reduce sin inverse. I mean, first part is to compare the given algebraic equation with some trigonometric formula for proper substitution. But how to do that substitution? The initial approach is same. We have to reduce the expression. Now, how can we reduce the expression? Either we will have to remove sin inverse, or we will have to remove this 2x upon 1 plus x square वाला part. किसी ना किसी part के साथ तो transform करना ही पड़ेगा छोटा बनाने के लिए इसको. And how can we do that? We have to, I mean, observe this expression. This expression will directly converge into some trigonometric formula. For example, in this case, 2 tan theta upon 1 plus tan square theta में मैंने इसको directly इसलिए किया क्योंकि वो मेरे को sin 2 theta बना के देगा. Now, sin 2 theta and sin inverse will help in reducing each other. So the expression will be only 2 theta. After this point, I'll reach to 2 theta only because sin inverse and sin cancels each other. And this will help me in final expression of this y. This is 2 theta and theta was tan inverse x. So this becomes 2 into tan inverse x. The whole expression reduces to 2 tan inverse x. Now, if you would have replaced x with sin theta, I fear that we won't be having any formula for 2 sin theta divided by 1 plus sin square theta. And this will not help in reducing the sin inverse. I mean, this will only make the problem more complex. There may be multiple formulae which can fit in, and you will understand which is the best one based on some practice. There is no particular method to that. But yeah, I mean, in most of the cases, there will be one formula only which will fit in directly, and which will help you to reduce that trigonometric function into some simpler trigonometric function. Also, you can remember this कि हमेशा ना लास्ट में एक्सप्रेशन थीटा के टर्म्स में होना चाहिए. The last expression will always be in terms of theta. Then you replace theta with the help of the substitution that you have done. अब हमने substitute किया था x is equals to tan theta. That is why I have substituted right back theta in terms of x, such as tan inverse x. So the final expression will be in terms of theta. जहां से हम then we will convert that theta into x with the help of ITF only. But the expression will be much simpler. Now you see that the differentiate, I mean, y is equals to 2 tan inverse x. How do we differentiate this? This is pretty easy. And 2 will remain constant, a constant and a variable in multiplication. So 2 will be same. We just have to differentiate tan inverse x, which is what? 1 upon 1 plus x square. And this process is very easy. Once you understand these, once you remember these formulae, and how do you remember these formulae? For that, you have to practice, at least 8 to 10 questions. Solve all the NCERT questions. You will understand that very quickly. These formulas are given generally same. They will just change the, they can change the inverse function, but the formula will be like this only. There are 8 to 10 formulae which are important. You will understand these 8 to 10 formulae once you solve 8, 10 questions, and then you will see the different varieties of the same problems. So this process will become easier after 10 questions. I instantly knew as soon as I saw 2x upon 1 plus x square that I have to replace x with tan theta, and then this will become sine 2 theta. The whole y will become y is equals to sine inverse sine 2 theta, which is 2 theta. As soon as I saw this, I was clear in my mind that y is equals to 2 theta, because I have solved these questions. No, the answer was same. My bad. 1 plus x square will cancel out 1 plus x square from numerator and denominator. So it will be only 2 upon 1 plus x square. It was written incorrectly. Right? So that is how we can solve the questions related to ITF. Now let's solve 2-3 more questions. I just need to know the right substitution. As soon as you provide the right substitution, you are done with the question. You have to solve 2 questions, and then I'll ask further some more questions. You'll have to tell me the substitution problem. Let's please everybody open the NCERT. Let's start with the question number 10. So the question number 10 is y is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. Guys, if you want me to write all the general formulae, I have told you guys, everybody, I've told you that please take a center page and write all the formulae for trigonometry, because I know that you will be using these again and again. In differentiation only, we will be using them again. Then we go to integration, we'll be using them again. Then we'll go to area bounded by 2 curves. Then differential equations, we'll be using them everywhere. So please make a center page in which there are all the trigonometric formulae will be written. They'll be, all for sum, difference, as well as basic formula, like sine pi by 2 minus x is equals to cos x and that. And then these identities for sine 2a, cos 2a, tan 2a. Then triple angle, these are called double angle formula as well as triple angle formula. Sine 3a, cos 3a, and then tan 3a. And after that, sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b. Then cos a plus minus cos b, then sine a plus minus sine b. And after that, 2 sine a sine b, 2 sine a cos b, 2 cos a cos b, formula for those. So you should have all the formulae in that center page. Now, if you want it, I can write it today, all the formulae, or you guys please complete it while we come in the next class, and take that center page always in that maths copy. Believe me, we'll be using them too much. So this is not an option to have that. Okay, cool. You can start the formula part. Well, write the important ones. You will have to complete basic ones. Important ones start from your 11th trigonometry, which is basically the first formula will be sine of a plus b, sine of a plus minus b, then cos of a plus minus b, then sine of a plus minus sine of b, then cos of a plus minus cos of b, then 2 sin a sin b, then 2 cos a cos b. Just a minute. Yeah. Then 2 sin a cos b, then 2 cos a cos b. There is another, I mean, you can also write it as cos a sin b, but both are same things. Right? 2 sin a cos b. I mean, you write sin first or cos second, or you write cos first or sin second. That doesn't make sense. You just have to understand that, I mean, the expression. So let's start with sin a plus b. Sin a plus b is sin a cos b plus cos a sin b. But if we replace plus with minus, then we just have this difference. So this will become sin a cos b plus, if you're using plus, then you will use plus here. If you're using minus, then you will use minus here. So this is plus minus. I mean, if this is written plus minus and this is also written plus minus, then it says if you whatever sign you take here, that will be the same sign here. So the sin a cos b plus cos a sin b. Or if you're writing sin a minus b, then sin a cos b minus cos a sin b. Now, in case of cos a plus minus b, it will change. This will be done in terms of, I mean, you can write it like this. This, first of all, in case of sine, there will be both sine and cos involved in both of the expressions. You can observe that. In the first expression also sin a cos b, and in the second also cos a sin b. But in cases of cos, only one expression will be involved. So if you're using plus here, then you will be using minus here. And if you're using minus here, then you will be using plus here. The signs will be different. So if you are writing cos a plus b, then it will be cos a cos b minus sin a sin b. And if you're writing cos of a minus b, then it will be cos a cos b plus sin a sin b. Right? Now, after this part, okay, yeah, my bad. I forgot. Tan wala formula bhi yaar sare yaad karna. Whatever is there for sine and cos, every formula will be in tan also, and you have to remember that also. This will be tan of a plus minus b. It will be tan a plus tan b if you're using plus here, and if you're using minus, then it will be minus, divided by, here the sign will be different. Okay. Then we go to sin a plus sin b and sin a minus sin b. I think we have to use two different things here. Okay. So first take sin a plus sin b. So sin a plus sin b would be 2 sin a plus b by 2 into cos a minus b by 2. And if you write sine of a minus sine of b, then it would be twice of cos a plus b by 2 into sine of a minus b by 2. Well, I mean, I will try to tell you the key parts in these formulae. I mean, how do I remember this? Obviously, first of all, that is practice. Without practice, you can't. I mean, I still can do a mistake in this. So there is always a chance of mistake, but the one of the key component is to practice. But the second component is you can remember some things associated. Like I told you in the first two properties that when you are operating on sine itself, I mean on sine, then you got sine and cos in both parts, right? But while you operate in cos, you got cos and sine. So both the functions were different, but one expression contains same function in case of cos. So now I am applying on sine again. So see, the answer contains sine and cos both. Sine, cos, right? Either you write sine A plus sine B, or you write sine A minus sine B. But while I operate on cos, then you can see that both of the functions will be same. So either sine or cos, right? So first of cos A plus B will be cos A plus B will be 2 cos A plus B by 2 into cos A minus B by 2. Simple, right? While you apply cos A minus B, I mean cos A minus cos B, then the answer will be minus 2 times sine of A plus B by 2 into sine of A minus B by 2. So both the formulae are like that. अगर सिर्फ देखो अगर साइन पे अप्लाई कर रहे हैं तो आंसर में साइन कॉस दोनों आएगा, बट इफ कॉस पे अप्लाई कर रहे हैं तो दोनों फंक्शन सेम होंगे. तो कॉस कॉस आया, देखो यहाँ पे सिर्फ साइन आया. ये तो सब चीजें याद रखनी पड़ेंगी. -2 कहाँ पे, +2 कहाँ पे, ये तो मतलब 2 तो सब नहीं है, बट माइनस सिर्फ इसी फॉर्मूले में है, ये याद रख सकते हो, cos A minus cos B. And another key component is so in case of sine, how do we remember which is sine and which is cos? I mean sine of A plus B by 2 or sine of A minus B by 2. So if there is a plus, sine goes with the sign which is written here. So if there is a plus here, then sine goes with A plus B by 2. If there is a minus here, then sine goes with A minus B by 2. Right? These are the things that you have to remember. This is how you can remember these things. Then we got 2 sine A sine B. 2 sine A sine B will be something, this will be some different formula. It is cos of A minus B minus cos of A minus B minus cos of A plus B. Cos of A minus B minus cos of A plus B. These formulae, by the way, are interconnected. One of the other method, one of the short method to remember them is if you know how to create them in the first place. How did this formulae occur? Okay, how we can form these formulae. So, and for that, you just need to remember the first two questions. First two properties, sine of A plus B and cos of A plus B. Even just remembering sine of A plus B will be enough. You can convert all of these. You can create all of the other identities with the help of sine A plus B or cos A plus B. And there is no trick to remember these three. These three you will have to remember as it is. Okay, 2 sine A cos B. Yeah, so there is one confusion here that either sine can be first or cos can be first. How do we interpret that? 2 sine A cos B or 2 cos A sine B. This can be similar like that. So we will write that expression also, but first we will understand this. So 2 sine A cos B will be sine of A plus B. Sine of A plus B plus sine of A minus B. Just a minute. Yeah. Sine of A plus B plus sine of A minus B. And let's say now in place of this, we have this. First, understand the concept. They both are same kind of functions. This is sine A cos B. भाई आप बस सिर्फ you are just changing the angles. First, the angle A was associated with sine. Now angle B is associated to sine. But हमें क्या पता है what how do we know what is A, what is B? वैसे भी तो I mean A and B are what? Variables. So A and B can take any value. For example, in practical cases, you will see questions like this: 2 sine 30 degree into cos 60 degree. Now we will have to solve this. How do we solve this? What is A, what is B here? You can also write the same expression like 2 cos 60 into sine 30. Both are same things. You just have to understand the concept part. So let's say if we are writing 2 cos sine B, then what do we do? Kuch nahi. We will write the same sine of both sum of both angles, sine of A plus B plus sine of, while taking the difference, you will always have to subtract the angle of cos from the angle of sine. In the first case, you have subtracted A minus B because the A was the angle with sine and B was the angle with cos. Similar thing you have to do here. Now the angle of sine is B and angle of cos is A. So it will be B minus B. Sine of A plus B plus sine of B minus B. Just remember this. This is nothing but when you multiply you multiply sine and cos, there are two different angles. So 2 sine A cos B will be sine of A plus B plus sine of angle of sine minus angle of cos. Then this is 2 cos A cos B. Did you understand this last one? If you have a confusion, please ask me. Feel free to reach out whenever you think there is a necessity or there is a problem. Yeah, so this is pretty easy. This is direct cos of A plus B plus cos of A minus B. Right. And also there is no identity related to tan A into tan B, and also tan is not applied in this case also, sin A plus sin B. There are identities, but we don't need to remember them. Saying that there is no identity. In fact, we do have identity for cot A plus B, cot A minus B also, but we don't need that because cot A plus B can be written as 1 upon tan A plus B, right? And that will help us. Important to note. Yeah. After this, we'll be needing what? We'll be needing double angle formula, triple angle formula. Sine 2x. Sine 2x is 2 sin x cos x, and can also be written as 2 tan x divided by 1 plus tan square x. Then we have formula for cos 2x. We do know that cos 2x can be written in many ways, and every way is important. So this can either be written as 2 cos square x minus 1, or can be written as 1 minus 2 sin square x. And then from this, another very important matrix is that you can write cos square x and sin square x in terms of cos 2x. So cos square x will be 1 plus cos 2x divided by 2. And then this will be 1 minus cos 2x divided by 2. Very important formula from cos 2x. Then we have tan 2x. Tan 2x can be written as, do someone remember this formula? Because we have discussed already sin 2x and tan 2x, and there was a very, the formula for tan 2x is also similar to sin 2x. Just one difference. Okay, 2 tan x divided by 1 minus tan square x. In place of plus, we'll just use minus. Yeah, also cos 2x can be written as one more formula for this. Cos 2x can also be written as 1 minus tan square x divided by 1 plus tan square x in the form of tan. We will be using them all. So write them all. Then after this, we can use the triple angle formula, which is sine 3x, cos 3x, and tan 3x. So sine 3x is 3 sine x minus 4 sine cube x. Then cos 3x is pretty similar, just the format is changed. 4 cos cube x minus 3 cos x. And after that, tan 3x, which is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So these you guys must remember, like cos 2x will be highly used. And all of the formulae, I would say, write them in a center page and always take them with you so that you can reach to that and solve the given question. Yeah, so after this, we can start with the question. Let's the question was, yeah. I think we were on which one? 4. So let's start with the 5th question now. 5th is y is equals to tan inverse 3x minus x cube divided by 1 minus 3x squared. Now first observe that if you have to solve this by chain rule, this will be a very lengthy question. You won't be able to solve this, easily. And there will be a high chance that you make mistake. Yeah, so to solve this, we must reduce the function first. And to reduce the function, you'll have to replace x with some function here. Now, first of all, observe which of the expression, which of the trigonometric identities written above resemble to this. If you replace x with what? Correct, Tharif. Tan 3x looks like it, right? If I just replace with, yeah, tan 3x. In place of x, if I use theta, tan theta, then it would be 3 tan theta minus tan cube theta, right, upon 1 minus 3 tan square theta, right? But also remember, while you do this, while you, try to equate this with an expression, always remember this thing, that what is the final expression after that? If you replace x with tan theta, what do you get? Tan 3 theta. Is that tan 3 theta reducing, helping us to reduce the whole expression? Yes, because tan inverse tan 3 theta will be 3 theta, right? So you have to actually proceed by taking two options in mind. That first, we will have to find out the correct formula, and also whether that formula is correct or not, validity of that formula. And validity will be that it must reduce the given expression. If it's not reducing the given expression, then it is of no use. So in this case, if I replace x with tan theta, right? If you replace x with tan theta, what is theta? Tan inverse x. So what I will do is, I will first reduce the given expression, which would be 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, which is nothing but tan inverse tan 3 theta, right? And which is actually 3 theta only. So if I even I would also like to enlighten you about why this x is given like this 1 minus 1 upon root 3 to 1 upon root 3. Generally, you have seen that whatever, I mean, tan inverse का domain तो हमेशा real numbers होता है, but I mean, we can put anything in place of x in the case of tan inverse. But in this particular case, why is this x like minus 1 upon root 3 to 1 upon root 3? Because 1 upon root 3 tan inverse, I mean, if you put x as 1 upon root 3 and you put it equal to tan theta, right? So if you put x as 1 upon root 3 here, so this will be tan theta is equals to 1 by root 3. So what is theta? 30 degree, right? Now the final answer is 3 theta. So 3 into 30 is 90. So that this 3 theta can be in between minus 90 to plus 90, जो कि actually domain होता है tan inverse का, sorry, range होता है tan inverse का. So to accommodate that range of tan inverse, it is given that x is from minus 1 by root 3 to 1 by root 3. I mean, this whole thing, whatever we are doing, will not be valid if x is greater than 1 by root 3. Then we have to approach with a different formula. And there are multiple formulas used in tan inverse, by the way. I mean, in general, if I say, then trigonometry uses a lot of formula. And why is that happening? Why we have to use so many formula? Because see, these functions are periodic. So they include angles. Angles are like from minus infinity to plus infinity, you can take any angle. But from 0 to 2 pi, there will be one rotation. And then 2 pi to 4 pi, 4 pi to 6 pi. So there are multiple formulae involved in trigonometry and inverse trigonometry due to these angles. But for our case, it is very simple. I mean, the domain will always be given like that only, so that you can use so that you can write this tan inverse tan 3 theta directly as 3 theta. If this x was given something else, let's say if x was greater than 1 by root 3, then this tan inverse tan 3 theta cannot be written directly as 3 theta. Then we will have to check what are the other possibilities. Yeah, so this is 3 theta, and we know that what is theta. Theta is basically equal to tan inverse x. So this becomes y becomes equal to 3 of tan inverse x. Now to find out dy by dx, basically differentiate the whole function with respect to x. So this becomes 3 by 1 plus x squared, which is pretty much simple compared to chain rule. No. Please start solving some more. Write the question. Let's first solve this one. Please do them. Tell me the final answer. First of all, tell me the correct substitution and then tell me the final answer. Whenever you identify the correct substitution, please share that answer with me. Then only proceed, because if your substitution is not correct, then you will not reach to the right answer. Oh yeah, what's the substitution? Correct, Austin. So we have to substitute x as tan theta and so that your theta becomes tan inverse x. And this will be 1 minus tan square theta upon 1 plus tan square theta, which will be cos 2 theta. This becomes cos inverse of cos 2 theta, 1 minus tan square theta upon 1 plus tan square theta, which is actually 2 theta. So basically y is equals to 2 tan inverse x. So dy by dx will be 2 upon 1 plus x square. Yeah, please just tell me the substitutions and you can solve the further part yourself. Come to page number 169 in your NCERT, exercise 5.3. You have to complete the whole exercise by the time you come in next class. Just tell me the substitutions here. So the 11th question is, 12th question is, y is equals to sine inverse 1 minus x square upon 1 plus x square. Y is equals to sine inverse 1 minus x square divided by 1 plus x square. What should be the substitution in this case? Sine inverse 1 minus x square upon 1 plus x square. Anyone? So I'm writing the question. The question changes to, if this was cos inverse, the substitution we know, right? Now it is written sine inverse. What should be the substitution? Anyone? What is the problem? If I substitute x is equals to tan theta as you did in the last case, what's the problem? The same question we have solved, right? Shahid, will you tell me what's the problem if I substitute x is equals to tan theta in this case? Chavez,
Sir, it will not be cancelled.
it will not cancel sine inverse, right? You will get cos 2 theta inside and it will not cancel sine inverse, right? That is the basic approach. So, but can we change that cos 2 theta, which is written inside this, into some form with sine theta? 2 cos theta can be written, cos 2 theta can be written in the form of sine. Okay, let's just do the same as we did in the last case. Put x is equals to tan theta. It means that theta is equals to tan inverse x. Now, your y becomes sine inverse, and this is cos 2 theta. But the problem is that it is not reducing sine inverse right now. So what? We have to further change it. This only means that we have to further change cos 2 theta in some terms of sine, right? Now, there are multiple formulae for cos 2 theta, right? Which we have used above. But if you use one of them, they won't give you any answer, any particular answer in this case. So what you will have to do, actually, we will have to change this cos to sine with inside some angle. I can write cos 2 theta like this, but it is of no use in this case because this will not reduce sine inverse with in any way, right? So what I'm doing is I'm writing cos 2 theta as sine pi by 2 minus 2 theta, sine 90 minus theta. You know that cos theta is equals to sine 90 minus theta. That is what I have done here. Now I can write this as pi by 2 minus 2 theta, right? So in some cases, you can see that the formula still, the formula given is valid, but this is not reducing the final function. That is what I told you, right? In the first question, that you will have to focus on two things. You have to approach the question from two angles. First is that some algebraic expression will be given that must replace a trigonometric function, that must have an analogy directly with a trigonometric function. And the second one is that it must reduce the given ITF. So if it's not directly reducing, then you have to change the internal function in some way so that it can reduce. Now it is simple. Pi by 2 minus 2 of tan inverse x. So if I differentiate dy by dx now, what do I get? Pi by 2 is basically a constant only, right? Pi is a number, a rational number. Pi is definitely a number. So pi by 2 is 0. Minus 2 will be minus 2. Tan inverse x will be 1 plus x, 1 upon 1 plus x square. So the final answer is minus 2 divided by 1 plus x square. Which square, Austin? I did not understand the question, please. Yeah.
Cos theta is equal to 1 minus 2 sine square theta, right?
But we
That's
have
what I'm
not
saying.
converted cos 2 theta into 1 minus 2 sine square theta. I was just telling you that we do have a formula for cos 2 theta. We have many formulae for cos 2 theta, but those formulae will not be valid because they won't be able to reduce sine inverse. That is why we are not using this formula. I was just telling you that this formula is also, there are multiple formulae for cos 2 theta, but why they are not valid? What do we have to do? We always have to approach it in this way, that we can just simply reduce cos 2 theta into form of sine and not like these using these formulas. I was telling you that. So we have not converted it. We have not reduced cos 2 theta into this. Rather than writing like this, what we have done is we have written cos 2 theta as sine of pi by 2 minus 2 theta. That we can write, right?
Yes.
Now sine inverse and sine are reduced with each other. We got pi by 2 minus 2 theta. Yeah, everybody got this? Okay, in that case, you'll have to finish the whole exercise by question number 15 and along with some other questions. Can I move this screen? Everybody done? Okay. What assignments for? So marking some questions, we have to solve them. Eighth, 10th, 11th. Today's date is 7th, right? Okay. 8th, 10th, 11th, 12th. All these 11 questions from this, and I think 5, 6 questions from